Hello, welcome you all for another session on mechanics of materials. So today I shall be starting a new topic. This content what I intend to discuss belongs to module 3 as per your syllabus. Module 2 we shall come back. I feel personally that covering module 3 and module 4, if I discuss module 2, that would be more meaningful and useful, and hence I shall go to module 3 straight away and then module 4 and then come back to module number 2. So today the topic, the title of the topic is beams. So module 3, now we are going to discuss what is called as beams. In module 1 all the time we are talking bars. Okay, you all know what is meant by bar. Long member having smaller cross sectional dimensions and subjected to only axial load. Okay, now what we are going to do, again the member remains same, long member having relatively a smaller cross section dimensions, but now the load is not along the axis, the loads are perpendicular to the axis. Okay, that is called as a beam. What is beam? Beam is a long member having smaller cross-sectional dimensions subjected to loads perpendicular to the axis. That is called as beam. So why we are studying mechanics of materials in this manner? Say bars, then beams, another topic something called as a shafts. So like that, we are studying, we are applying only one type of load and understanding what is the effect. But really in a machine or in our practical use, we are not going to have an ideal, strictly speaking, a bar or only beam or only shaft. Okay? We are not going to have like that. The member doesn't know what is its name. It is going to be subjected to all kinds of loads. Loads along the axis, loads perpendicular to the axis, loads about the axis. All these loads are going to be there. That is what we ultimately aim to study. But we can't study straight away, jump there and study, no. So we make it our study simplified. First we assume that it is subjected to only loads along the axis. Now we are going to take the study of loads perpendicular to the axis only. Then what happens? Then we shall have a load about the axis. What happens? Then we shall club all this, and that's what we are going to make the study. So the study has been made simplified by taking only one type of load at a time. Load along the axis, load perpendicular to the axis, load about the axis, like that. Okay, that is why we have another case now, the beam, which is a member which is subjected to loads perpendicular to the axis. So maybe beam may be horizontal, beam may be vertical, beam may be inclined in any direction. Many times beam, we say the moment immediately we normally draw it in the horizontal direction. Don't be under the impression that beam is always horizontal, not necessarily. It may be a vertical beam also, it may be inclined. But I shall draw it, say something like this, a member. Okay, say this is the axis, maybe circular, maybe rectangular, it may have any cross section, doesn't matter, or triangular. Say this is the cross section. So can I call this as beam? It is only a member, it is not subjected to any load. Unless it is subjected to any load, okay, it won't become perfect. So now you have load something like this. I have a load, I have different loads. So I shall tell you what are the different types of loads also, or I may have something like this. So these are the different load. Load means it includes force and also moments. When I say load is a term which includes both forces and moments. And what are the different types of forces? Okay, then all that we are going to discuss a little later. Okay, now we are under the action of this load. Now is it a member? Is it a member which is subjected to load? This is the load perpendicular to the axis. This is another load. What is the name of this, etc. I shall tell you. And this is another load. This is a moment. So all these are perpendicular to the axis. Therefore, okay, therefore we say that. Can I call it as a beam? Now under the action of all these loads, this will fall down, no? Okay, the member will fall down, or even if I remove the load, the member has to remain there. So therefore, for that purpose, you require what are called as supports. Every beam requires supports. Okay, support is nothing but, okay, it is in a form of what is called as you are providing certain reaction, you are holding it, you are supporting it. There is some other member which is making them to remain in that position. That is what we call it as support. Support is essential for a beam, but it is not part of the beam. Okay, when I take isolate beam, then I also have to show what forces are offered by the support on the beam. That also I have to take. Okay, support, the moment I say, so if I hold it, say something like this, if I make it like this. Okay, supports are different way. See, this is one kind of support. So this is one support. Or a support may be something like this. This is a support. So where you are going to have beam portion here, and this is what is your beam, and it may be like this also. There are no rollers here. This and this, both of them are one and the same. There is a roller here, and you have a beam. This or this, both of them are one and the same. Okay, I am discussing the names of these beams in the reverse way. These are the standard ways of representing various supports. What support does? Support basically does restriction on the movement of the beam. Say if you put a wall, okay, to the room and you have only one door, no, that means only through the door you are going to enter, and all other walls are preventing any motion. And similarly here also, the support is going to put certain restriction on the movement of the beam. So what are the different possible movements of the beam? Here we are talking about planar forces. We are talking about the planar forces, and what are the different ways. Say if you imagine that this is a portion of a beam, say imagine that this is a beam. So what it can move? It can move along a horizontal line, or it can move along a vertical line. So any inclined line also is a combination of horizontal and vertical, I can say. And then what are the third possibility? The rotation. So beam, what are the different possible motions for a beam in a plane are only three. The different possible motions are motion along x, motion along y, and the rotation. These are the three possible motions of a beam. And these motions are going to be restricted by the support. Okay? So then accordingly, then we are going to have the names. See, this is called as fixed beam. Fixed support. The support is called as fixed. This is how we are going to indicate it. We draw a line and hatch it. That is called as fixed. So what are the things that are restricted? We are not going to have x direction motion. We are not going to have y direction motion and rotation. All are restricted. X motion, y motion, and restriction and rotation, all of them are restricted. That means if you have to restrict x motion, there must be something. If you don't want this to move in this direction, then there must be something here. Okay, or in other words, you have to apply some force. And similarly, y motion is not to be allowed. That means there must be some force there also. And the rotation also is not allowed. That means there must be a moment also must be applied. That means this fixed support, what are the forces, what are the reactions it is going to offer? It is going to offer a horizontal force. This fixed support shall offer a vertical force. It may be in the other direction also. depending upon what are the forces. Then it is also going to offer what is called as a moment. The moment also. These three. If I need to replace this support, then I have to replace it by a horizontal force, a vertical force, and also a moment. That is the meaning of fixed support. Fixed support shall put all the restrictions on the motion of the beam by offering horizontal force, vertical force, and a moment. And that kind of beam is called as, that kind of support is called as fixed support. And this support is called as roller support. This is a roller. This is a hinge along with the roller. This also is called as hinge along with the roller or roller support. Both of them are roller support. Here you can see here. This is how you have rollers here, and this is the beam. I am showing only the center line of the beam, the axis of the beam, the complete portion of the beam. I am not showing the cross section. So here, what are the things possible? Okay, the moment can you have whether the beam can leave the support and go in the y direction, whether y movement is it possible? If it makes contact, then there is no support, and we say that the support is not playing its role. Support and the beam, they are always in contact with each other, and therefore, so y movement is not possible. So if I call this as y motion is restricted, y restricted, motion along y is restricted. Can you have x motion? Yeah, you can have, because if to move this also can move. So therefore, x motion is not restricted. And what about the beam which is like this? Can it rotate? Yes, it can, still in contact with this, and the rotation is possible. That means the rotation also is free. Rotation we are not stopping. X motion we are not stopping. We are stopping only y motion. And therefore, if I replace this support, then I can show that there is a force here in this way. This is the what we call it as the reaction. The reaction offered by a roller support is always perpendicular to this support, and if it is like this, then we have y in the y direction. Sometimes the beam may be like this, and I have a roller like this. I have a support like this. In that case, perpendicular to this, you draw a line. This is the reaction, and you can remove this. So therefore, the roller on what surface it is resting, draw perpendicular to that surface, and you will get what is called as the reaction. And therefore, the reaction offered by a roller support is only one, and the other two motions are possible. And this is called as roller support. And the third one is what is called as this kind of motion, this support. Here there are no rollers. Here there are no rollers. If this is again fixed, this is called as hinged joint, hinged support, and this is the beam. So what are the different possibilities? Can I have x movement? This is fixed. Therefore, that movement is not possible. The movement in the x direction is not possible. That means x motion is restricted. And similarly, can the beam move in this direction? That also is restricted. The motion in x direction, the motion in y direction, they are restricted. And what about the rotation? The beam can rotate. And therefore, there is no restriction on the rotation of the beam. Therefore, to stop this or to stop this motion, you need to have a force in x direction. You need to have a force in y direction. And therefore, always the hinged joint shall offer two supports, one in y direction, the other one in x direction. Whatever the direction, it may be this way or it may be downwards, it doesn't matter. So therefore, you need to know what are the different reactions offered by these different. A fixed support shall offer horizontal reaction, vertical reaction, and a moment. Roller support shall offer reaction only in one direction, say y direction, and hinged joint shall support in x direction, that means reaction in x direction, force in x direction and reaction in y direction, and moment is 0, there is no moment offered by it. Okay, these are the various supports. Using these supports we form beams. Using these supports we form beams. Okay, so I can have a support. Sometimes I may require what is called as, I hope you have understood what is beam, that I have answered, and what are the different supports, that also I have answered. Fixed support, the roller support and hinged support. What kind of reactions they offer, that also you have understood, very very important. Now we are going to go through what is called as types of beams. Okay, say I have a beam which is like this, only this. Okay, only the center line of the member I have shown, and this is what I call it, the beam, and say it is subjected to, of course, unless it is subjected to any load, it is meaningless. Okay, this is called as a cantilever. This is called as cantilever. How do you describe cantilever? Of course, you have a beam. So, what kind of support? Okay, this is one end of the beam, this is the other end of the beam. One end of the beam is fixed. And what about the other end? The other end there is no support. Okay, we have only one support, that is fixed support, and that at one end of the beam we don't have any other support. This is called as cantilever. Okay, so by chance if I also have a fixed here, then we say that both ends fixed beam. That beam is called as both ends fixed. Okay, fixed ended beam. This is called as cantilever. Cantilever has one support. Okay, then we have something like this. Okay, or this also. Both of them will do. I have a beam at both ends, ends only. I have roller supports. Okay, here I have one roller support and one hinged support. Okay, both of them are called as simply supported beam. This is called as simply supported beam. Okay, this is called as both roller ends, or here one roller and one hinged. This is called as simply supported beam, and the distance between the two supports, whether this or this, okay, this is usually called as span. The distance between two consecutive supports. Sometimes the beam may be very very long. I may have more than two supports. I may have a number of supports. That is called as a beam having more than two supports is also called as a continuous beam. You have support here, 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 here. Or beam goes on, you have hundreds. Say bridge. See, it is a continuous beam. You have a number of supports. So the distance between two consecutive supports is usually called as span. The span of the beam. Okay. So this or this is called as simply supported beam. This is cantilever beam, and this is called as simply supported beam. And we have a third one. Actually, this since all books also mention that it is a type of beam, I also mention it from the sake of the examination. Otherwise, it is not different. Overhanging beam. In simply supported beam, we don't have beam portion beyond the support. Okay, this is the support. This is one side, and this is the other side. This is what I mean by beyond beyond support if I go, there is no beam. Similarly, coming this side, you have beam, and if you cross this support, you don't have beam. Beam portion is not there beyond the supports. That is called as simply supported beam. So here, overhanging beam. So there is some portion of the beam beyond the support also. Okay, so I can have different types of overhanging beam. So I can replace this roller support finally by a kind of what are called as reactions. Then I have something like this. Okay, there is a beam portion beyond the support. So please remember, this support or this support, they indicate the same thing. As I said earlier, this is going to restrict only Y moment. So for that, I have force only in that direction. The support offers force in only one direction. That's what I have done here. Similarly, here also you can replace it. Okay, so this is called as overhanging. On which side you have overhanging? Overhanging beam on the right side. Right side overhanging beam. This is called as right side overhanging. So can you have the beam of similar type, left hand over side, left hand overhanging? Yeah, something like this. You have a beam here and here. These are the different loads. This is called as left side overhanging. Left side overhanging. Okay, so then can you have overhanging on either side? Yes, it is possible. Both side overhanging. I want you to draw the diagram for that. Both side overhanging. Both side overhanging beam. Left side, only right. Okay, left side, yeah, left side, right side, like that. Okay, the overhanging comes on either side. So what is the span here? The span is this only, please remember, this is span. So this is a span. This is called as span. The span is the distance between the two consecutive supports is known as span. I hope you understand. Okay. So these are all beams what we are going to study in our course, and all these three beams we call them as statically. All these three beams are called as statically determinate beams. Statically determinate beams. So any other beam, like depending upon, say I have two fixed supports, say something like this. So I have one, and I have another one, and I have load like this. This is called as both ends fixed. Or if I have this one and this one, this also, and I have a load, and I have load like this also. Okay, inclined load, something like this. Okay, like this. Both ends hinged. Okay, these are called as statically indeterminate beams. So not just, you may have any combination, one fixed support and one roller support also, something like this. Even if you have like this also is called as statically indeterminate beam. And in our course, we are not going to study statically indeterminate beams. What do you mean by statically determinate and statically indeterminate? Okay, it is quite simple. So ultimately, we want to find out what are the reaction forces offered by the supports. It may be horizontal force or vertical force or moment. These we call them as reactions. Reactions offered by various forces. Okay, so if I am able to find out the magnitude and directions of these, or in general I say if I am able to find out the reactions offered by the supports using only equilibrium conditions. I hope you remember equilibrium conditions. Using only equilibrium conditions, then such beams are called as statically determinate beams. If I am not able to find out the reactions offered by the supports using only equilibrium conditions, then I call them as statically indeterminate. I cannot find out the reactions offered by the supports using equilibrium conditions. I raise my hands and I can't determine using equilibrium conditions. Such beams are called as statically indeterminate beams. Okay, in our course here we are not going to consider, therefore that's why I said we are going to have cantilever, we may have simply supported beam, we may have any type of overhanging beams, all that. I can say that these are all statically determinate beams, and hence I can find out the reactions very easily, and therefore that is what we are going to do now. Okay, in the next few, maybe one session itself I may take, or you all have done already in applied mechanics or elements of civil engineering, you have done this. And determining the reactions offered by the various supports, we need to do it. And for understanding this topic or later on what we intend to do, and it is a must. Therefore, I shall take one example. Say I have a beam. Say I have what is called as, what is the support? Roller support. And I have another one here, hinge support. And say I have forces like this. Say this is 50 kilonewton, and say this is 20 kilonewton, and say this distance is 1 meter. Say this distance is 2 meters, and say this distance is 1.5 meters. Find the reactions offered by the supports. Find the reactions offered by the supports. That is my problem. Okay, what I do, I draw this, the same thing, whatever here, and this. And here I have a roller support. And we all know that the roller support will offer only one reaction, and in this form. And I shall call this C, this is A, and say this is B, C, this is B, and I shall call it as R, A. R means reaction. Okay, so reaction offered by the support at A, that I call it as RA. So why did I take upwards? Okay, so I have taken it randomly. By chance my assumption is wrong, then it may be the other way, it may be in the other direction, no problem. And then I have a force, what is that? This is a one more force. And what are the forces offered here? So we know that it is a hinge support. It will have reaction in the vertical direction, and it will have reaction in the horizontal direction also. Okay, so now what is this? This is RB, call it as vertical. And I also have what's called as RD horizontal. So I am supposed to find out what's called as 50 kilonewton, 20 kilonewton, this is 1 meter, this is 2 meters, this is 1.5 meters. Okay, I am supposed to find out RA, RD, RDB, RDH, and the square root of this square plus this square is nothing but R. Okay, so now, so how I do it? I know that under the action of all these things, this portion is in an equilibrium state. So therefore, apply the equilibrium conditions. What is that? Sigma F along the x-axis equal to 0. Sigma F along vertical direction or y direction equal to 0. And sigma m about any point is also equal to 0. So this is how I find out. Okay, so sigma fx. So any force in the x direction, this is a y direction, and this is y direction, this is y direction, this is y direction, this is the only force in the x direction, and therefore make use of this and say that RDH is equal to 0. RDH is equal to 0. Okay. So now the next one, sigma Fy equal to 0. What is that? Okay. RA is in the upward direction. Make use of this. What is this? RA, the upward force. And what about this 50? 50 is in the downward direction. Minus 50, then minus 20 plus RD vertical. This is equal to 0. Simplify this. Then I take, okay, you will not come to know both RA and RDV. Both of them are unknowns. You will come to know RA plus RDV is equal to 70 km. Now I take moment about any one of them. So I take sigma m about A equal to 0. Okay, let me take moment due to all the forces about point A equal to 0. Okay, so 50 multiplied by 1. So I start with 50 kilonewton and write it. I am writing this 50 into 1 as plus. That means unknowingly I have made a sign convention that clockwise moment is positive. Then 20 kilonewton above it, this also is clockwise. Therefore this is plus 20 multiplied by, what is the distance between this and this? It is not 2, it is 2 plus 1, 20 into 3. Then the next one, RDH is already 0, that I know. Then RDV, the moment due to this RDV about A is in anti-clockwise direction, therefore it is minus. That is RDV multiplied by the distance. 1 plus 2, 3, 3 plus 1.5, 4.5, this is equal to 0. So therefore, you take this 50 into 1 plus 20 into 3, 60, 50 plus 60, this is 110, this is equal to RDV divided by 4.5. So simplify this, you come to know what is RDV. RDV is equal to so many kilonewton. Substitute this here. You will come to know what is RA. Okay? So RA is known, RDH is known, RDV is known. That means all reactions we are followed. How did we find out? How did we make use? Using only equilibrium conditions. If you try a similar one using this, you won't be able to find out either for this or for this, and that is why these beams are called as statically indeterminate beams, these ones. And this thing is called as statically determinate. So this exercise we are going to do it for a couple of more rounds, practice, and that is a must. And we shall stop now. We have understood what is types of beams, what we studied, and we shall understand what is types of loads, and then take on what exactly is our main course of study in this topic, that in the probably next class. All the best.